Hi guys, good morning. So in the last session we saw about interval and routing concept, and we went with the three methods: router with separate interfaces, router on a stick, and with the layer three switch. These three methods we saw. Okay. So today we'll start with the next topic, which is about spanning tree protocol.
All are requesting for Wi-Fi, right? Yeah, we have given we have created the group, so please access to.
Okay. So today we'll see about spanning tree protocol. In short, STP. So tell me, what did you check about STP? It's a open standard 803.1D. Every switch comes enabled with STP. It is a layer 2 protocol. It is used to prevent layer 2 leaks. It is used in micro redundancy, like multiple parts is there. It will block one port. Ensure like one part should be there to for every device. There should be one part. Okay. Yes. You're not going through it. Yeah. Interviews doesn't work like this. Say it. Yes. Don't know. You didn't study in CCM? Huh? You didn't remember. Yes. Desirable. That is, yes, next. Come again. The last statement. What was the complete statement? Say again. Start. It will create a redundant link. How? Okay, please complete it. I'll tell you later. So we can negotiate from other pairs, and pairs are floppy. Pairs are floppy. Receive and forwarding. And roles are root code, forward and block code. We have multi-type like CPSC, okay. Yes. You. Hmm? No. 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 2 days. Enjoy. Hmm? Yes. Last. No. Huh? Forgot. Online people. STP.
Yeah, so spanning tree protocol, I mean, it works on a layer 2 of the voice model, which helps loop free. So that is, it will ensure that the redundant port does not allow traffic forwarding.
Correct. Anybody else online?
It's a loop avoidance protocol. It's by default Cisco switches is enabled this STP. Yeah, one port is block port and another is forwarding stage.
Okay.
By
And-
BPDU message, find out the road port and road bridge and on-road bridge switches. According to the selection, road port election is happening.
Okay. Anybody else online?
Sir, it prevents the loop in the system by
System.
providing so in a network, sorry, by providing a single active path.
Okay. Anybody else? No? Okay. So almost everybody is right. So first thing is STP stands for spanning tree protocol. Okay. It is used to avoid layer 2 loops. Right? Okay. Now this is also a layer 2 protocol. You can say STP is a layer 2 protocol and it is used to avoid layer 2 loops. Okay. How it avoids layer 2 loops? By finding redundant paths. By finding redundant paths and putting in blocking state. So simply you'll say it is used to avoid layer 2 loops by blocking a loop. So you can say link or in some cases redundant link. That is also okay. But it's not always the case that there will be a redundant link. Still, it can work. So that's why I'll just say by blocking a link. Okay. Now, before we move forward, we say that it's a layer 2 protocol. It is used to avoid layer 2 loop. But how the loop is created at layer 2? Because it switches broadcast to like floods the broadcast to every interface except if it's received down. So if that is if A get a broadcast, it will send to B also C, and again the C B will send back to A, and this will. Okay. Anybody else? How the loop is created? Two switches or three switches. Will go to another
Multiple layer.
another line it will going and it will create a loop. To avoid that, so simply whenever you're asked that how the loop will be created, so you can simply say that at layer 2, a loop can be created because of broadcast traffic. Then to further explain, start it like you have two switches or three switches. Don't directly say A switch is there, A will send to B and C. Because I don't know how many switches you have assumed in your topology. Right? So whenever you take an example, make sure first you tell that, okay, this is my topology that I have three switches interconnected to each other. Okay. So now if we take an example, let's say for example, I have three switches. Switch 1, switch 2, and then I have switch 3. Okay. These are connected to each other. And right now I'm not using any redundant link concept. These are the three switches. We'll say switch 1, switch to switch 3. Switch. These are the 3 switches. Now I have F0 by 1 here, or according to the E topology that we will be practicing. So say Z0 by 0, Z0 by 1. Okay. Z0 by 0. Z0 by 1. Z0 by 1. Z0 by. Okay. So this is how they are connected. Now let's assume that a host is connected to this particular switch. Say this is one host connected to the switch, right? So if this host is going to generate an ARP here, everybody knows ARP is what? A broadcast. ARP is a broadcast. So how a switch deals with the broadcast message? How a switch deals with the broadcast message? So all the ports except the port it was received on. So that means this broadcast message will arrive on this side, as well as this will also arrive on this side. So first let's consider that. So first we will consider that this message arrives on switch 2. Now how switch 2 will deal with it? Forward on this side to the switch 3. How switch 3 will deal with the broadcast? Forward to switch 1. How switch 1 will deal with the broadcast? Correct? Okay. Then let's assume the second message that also arrived on this side. So what will happen? Switch 1 has forwarded to switch 3. Switch 3 will forward it to switch 2. Switch 2 will forward it to again. This is how the loop will get created. So at a time there will be 2 loops. One in the clockwise direction, another one in the anti-clockwise direction. Correct? So to avoid these 2 loops, okay, to avoid these loops, we have what protocol? STP. Okay. So this is what. Without loop, and then layer to loop because of broadcast. Right? This message, this is what basically say out here. Okay. So here we have two loops, one in the clockwise direction and one in the anti-clockwise direction. And what will happen that if we have redundant link also here, an STP protocol is not there. So what will happen? This traffic will keep on increasing. This traffic will keep on increasing. So if this traffic will keep on, and this is just because of 1 hour from one PC. And if I'm working in an organization with thousands of PCs, you can imagine the amount of broadcast traffic that will be there in my network. So this will cause a condition that is known as broadcast storm. Okay, this broadcast traffic will cause a condition which is known as what?
Yeah, and another problem is there is no TTL.
Mhm.
Right,
Correct.
no, sir? Yeah, there is no because that is why otherwise the packet because after the TTL get expired, it will get dropped, but that will not happen in this case.
That is for layer 2, layer 3, right?
That's what sir. In layer 2, we don't have TTL mechanism for layer 2 forwarding. That is why it is continuously on the loop.
And even though if you have TTL also, okay, TTL gets reduced by 1 only if it is forwarded by a layer 3 device. So this is a layer 2.
Right.
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 That- So the broadcast traffic in the network leads to a broadcast storm. The broadcast storm will consume heavy bandwidth and CPU, which will eventually this will eventually bring your network down. Here, this is why we need STP. All right. Now let's see. Spanning tree protocol enables switches to become aware of each other through the advertisement and receipt of BPDs. So we'll come to it. What is BPD and not? Okay, directly they are just talking about stage sport. Okay, then first I will explain, then we will go through this. Because directly here they are starting with the root version of. So the layer 2 loop has been crossed. Now to avoid this layer 2 loop, what do we need? STP. And how STP is going to work? STP is going to work by blocking a link. This is how STP is going to work. Right? Okay. Now how STP makes blocking decision? how STP makes blocking decision, that which port to block. First, it will select root switch. After that, root port. Then designated and department blocking. So STP makes blocking decision by selecting a reference and making some elections. Okay, what kind of elections your STP is going to make? The first election the STP will make is root bridge election. Okay, second election it will make root port election. Third, designated port election. Fourth, alternating port election. Okay, and this alternating port will be the blocking port. Clear? And when we are talking about this reference, this is what basically root bridge. This is your root bridge. Clear? Now, to select the root bridge, we have some election criteria. And to understand the election criteria, we need to understand few more terminologies, like what is the BPDU, what is the default priorities, then cost. These all things we need to understand. Okay. So first of all, let's talk about the BPDUs. That what is the BPDU? Okay. So I'll take the first statement from here, that what STP does. Okay. Spanning tree protocol, STP enables switches to become aware of each other through the advertisement and the set of the bridge protocol data units. Okay. And if we talk about BPDU, what is a BPDU? Or in other words, we can say STP STP switches communicate with each other by exchanging BPDU messages. Okay. And what is BPDU? Stands for Bridge Protocol Data Unit. This is what BPDU is. Okay. And this BPDU contains a lot of information. Okay, what is the information present in a BPDU message? Let me show you. Okay, here it's not given. That is strange. Let me show you in the CC. Okay. See, these are the messages. So a BPDU contains a lot of information like protocol identifier, protocol version, BPDU type, flag. Then the information that is present is root bridge ID, okay, the host, sending bridge, sending port, what is the message is, max is, hello time, and power delay. Okay, so this is the information that is present. And these are both the types of BPDUs, that is configuration and TCM. So if you want, you can make these diagrams about the configuration BPDU and TCM BPDU. For configuration BPDU, this is for TCM. Now, as of now, of our interest, let's say if you want to elect the root bridge. So there is one thing is there that is of our interest, which is about the bridge ID. Okay. Initially, this is not the one, this is the one sending bridge ID. Because root bridge, once it is elected, then root bridge ID information will be there. Initially, all the switches, they will consider itself as the root bridge. Okay. So the sending bridge ID information, this is of our interest. That means in the BPDU message, right now what we are interested in is the bridge ID. Okay. So if we talk about bridge ID, what is the bridge ID? Anybody aware? It consists it is two parts, bridge priority and MAC address. So bridge ID is basically a combination of priority plus MAC address. This is a combination of priority and MAC address. MAC address, every single switch is going to have different, and priority is there. Okay, default priority is available. If we talk about default priority, so that default priority is 32768. This is the default priority. Clear? Okay. Now, let me take away this diagram. So let's consider every switch has this thing, right? So I'll say for an example, the switch one has the priority 32768, right? And the MAC address for the switch M1. Okay. Then this switch has the MAC address M2 and priority is again 32768. Okay. And this one M3 and date is 32768. Here. Now, the first election will take place. So bridge ID is clear. After bridge ID, we also need to take a look for the cost. Every interface is going to have some cost. Okay, so if I show you about the cost is there in this here. Okay, so we have a short mode and we have a long mode cost. Okay, so this is for high speed links, this is for slow speed links. Okay, so like if you have a 100 Mbps link, your cost will be. If you have a 1 Gbps link, your cost will be. If you have a 10 Gbps, your cost will be 2. Okay, so as of now, I'm using gigabit links. That means 1 Gbps, my cost should be 4. Okay. So as of now, you can note down only these three: 100 Mbps, 1 Gbps, and 10 Gbps. No need to note down all of them. Because in short mode, more than 10 Gbps, everything is one only. Okay. Okay, these three you can note down. 100 Mbps is 19, 1 Gbps is 4, 10 Gbps is 2. This is about the STP cost. Got it? Okay, 100 Mbps is 19, 1 Gbps is 4, and 10 Gbps is 2. Now, so according to this, my cost, if I take a look, so here my cost, this is gigabit link 4. Okay, for gigabit link it is 4. For 100 Mbps it is 19. For 10 Gbps it is 2. So, 4. This is my cost. Okay, now let's talk about the first election, which is about root bridge election. So number one, root bridge election. Okay, if we talk about root bridge election, so what is the election criteria? Okay, so least priority will be checked. Okay, first least priority will be checked, and then if priority is a type, which will be the default case, least MAC address will be checked. Okay, now let's take a look here. According to this, so first of all, let's check the least priority. So everybody is having the same priority. Then we have to check the least MAC address. So that means M1, M2, and M3. Which one is the least? M1. So that means this guy is going to become what? Root bridge. This guy will be root bridge. So once this guy became a root bridge, these people, they will become non-root bridge. They will be defined as, okay, or in short, I'll call them as an enable. This is a non-root bridge. This is also non-root bridge. Okay. Now, second election will take place. That is about root port election. Number 2 will be what? Root port election. Now, how the root ports will be elected? So, your root ports, you can say, first of all, these are found on non-root bridge switches only. Your root bridge will never have a root port. Second, how these are found? These are least cost path to the root bridge. Least cost path to the root bridge. And the third thing is they are always in forwarding state. They are always in forwarding state. This is clear. Now let's see where the root port will be there. So see here how the root ports will be elected. So first of all, root ports are found only on non-root bridges. Okay. So let's talk about switch 2. Switch 2 will calculate the cost from this path. So when switch 2 will calculate the cost from this path, switch 2 will say, if I go with this path, my total cost is what? 4. Yes or no? And then switch 2 will see that, okay, what if I go with this path? 4 plus 4. So my overall cost through this path is 8. So where I have a least cost? Via G0 by 0 interface. That means this is the interface I'm going to elect it as. I'm going to elect it as root port. So this my interface will be elected as root port. Right? Then similar calculation here, switch 3 will make that, okay, if I'm going via this path, my total cost is 4. And if I'm going via this path, my total cost is 8. Again, I'll check the least cost, that through which interface I have the least cost. So through which interface I have? I have it through Z0 by 1, not Z0 by. I have it through Z0 by 1. So that means this interface will be elected as root port. Here. So now my root ports are elected. After root port election, the next election will take place, which is about designated port election. Okay. So that will be the third election. Designated port election. Now, first thing about your designated ports, your designated ports can be found on root bridge and non-root bridge. These can be found on root bridge as well as non-root bridge. Second thing, how you identify them? So you can say, in most cases, the ports directly connected to root ports. Okay, those are what? Designated ports. Okay. Or you can say all ports of root bridge have designated ports. In short, okay. Then they are always in forwarding state. And there's one more point that each link is going to have a each link should have a designated port. Noted? Okay. So first thing is it can be found on root bridge and non-root bridge. Any switch it can be. Then any port that is directly connected to root port. So this is the root port. This is the directly connected port. This is the root port. This is the directly connected port. So both the ports should be. So I said the third statement that all the ports of the root bridge should be designated ports. So this is my root bridge, and all the ports of this root bridge are what? Designated ports, right? Okay. Then these are always in the forwarding state. And one more point is there, which is about each link should have a designated port. Okay. So as of now, I know that, okay, this is my port, which is going to be designated port. This is my designated port here. And this port here is also what? Designated port. Correct. So this link is having a designated port. This link is also having a designated port. What about this link? Does it have a designated port? No. Okay. So how do I elect a designated port here? First, we need to how? Without designated port, you cannot find alternate port. So we need to make a decision about designated port here. This is the last designated port, right? So how do you find it? See, root ports in the designated port is there. Yeah, see here. That the switch with the lower path goes to the root bridge will forward, and the other with the higher path course will be blocked. So first of all, what will be checked? Lower path course. That which switch is having the lower path course, right? So if I check here, that which switch, now all these here all are elected, right? So I have path cost for the switch 2, which is where G0/1 interface going from this to this. What is the cost? 8, right? Okay. Then switch 3 will check its own cost. That okay, I also have this path. What is the cost? 8. Same. That means can I use the path cost here? No. So first criteria is not working here. Let's go to the second criteria. So if this is a tie, in that case, what will be checked? Priority will be checked. So that means who have the lower priority, right? So if we check the priority of these two switches, 32768. Here also 32768. Priority is also a type. Then what will be checked? MAC address will be checked. What will be checked? MAC address will be checked. So according to MAC address, this is M2, this is M3. That means who will become the designated port? M2. Okay, switch 2 will become the designated port. So this port will become what? Designated. Now in some cases might be that here itself more than one port is there. In that case, multiple ports will have the same MAC address also. Okay. So if that is the case, okay, if the links are connected to the same switch, then they will go to the next step. Okay. Which is about port ID. Which is about the port ID. That means lower port number will get the priority. Yeah. But in most cases, the MAC address will be a tiebreaker. Okay. This is clear. Okay.
Sir, last point, can you come again?
See here that first thing is what we checked about. We checked about the cost. So cost for switch 2 and switch 3 equal. If cost is a tie, we go with the priority. So we check the priority. Priority is also the same. If priority is a tie, we go with the MAC address. Okay. So MAC address means what? We will check here M2, here M3. So that means who is the lower MAC address? Switch 2. So switch 2 will have a designated port. Here. Now in case if from switch 2 also multiple links are there. So in that case, MAC address will also become a tie. So in that case, lower interface ID will get a priority. Okay, that will be given preference. So that means let's say we have Z0 by 1, then Z0 by 2. So which one is the lower? 1. So 1 will become the designated port and automatically the other port will be blocked. Yeah.
Okay, sir. Thank you.
Yeah. Now we have elected the designated port. So from the designated port, all our conditions are satisfying now. Okay. Now, the last election is about the alternating port election. This is the last election. So simply you can say that all ports other than root port and designated port are alternating port. Okay. These are in blocking state. These ports are the ports which are in the blocking state. So only one port is left in our topology, which is about switch 3 Z0 by 0 interface. Okay. So this will be the alternating port. So basically what it means that the switch is going to block this port. This is the link that will be Clear? Now, if this link will be blocked, now what will happen? So this will be a kind of situation that this link itself is not available. This is a kind of condition that this link itself is not available. So in this case, now if there is a broadcast message, so it will forward it here and here. But can switch to forward this side? No. This will not be forwarded. Can switch 3 forward it this side? No. Cannot forward it. And this is how your STP will prevent the loops. Okay. Yes. Okay. This is clear. So this is the link that your STP will block, and our eventual network will be this. Okay. This is the logical. Because in the real scenario, the link will still be there. So the logical representation. After STP blocking. Here. And this is our ARP message. Any doubts? Okay. Let's see. Now what it says. We'll come to the states. And also I'll explain about these protocols. States terminology. First, let's go with this thing. Coast. So the root path is found based on the cumulative interface STP coast to reach the root bridge. And these are the some coasts that are there. Okay. And we have two modes. One is the short mode and another one is the long mode. Okay. But what is the original method you can see? The original method known as the short mode is the default mode. Okay. Then how root bridge is elected? So as a switch initializes, it assumes that it is the root bridge. Initially, when the switch will come up, first all the switches will assume what? That they are itself the root bridge. And in the root bridge ID, right? In this portion here, in the root bridge ID portion here, what they will use? They will use their own ID. And they are going to use the local bridge identifier as the root bridge identifier. That means basically initially when your STPs when your switches come up, an interface comes up, switches will send the STP message, BPDU. In the BPDU, they will tell that, okay, I am the root bridge. Every switch will say that, okay, I am the root bridge. And then they will start listening to neighbor. Okay. They will start listening to the neighbors BPDUs. Clear? So when they are listening to neighbors BPDU, if the neighbors BPDU is inferior to its own BPDU, if the neighbor's BPDU is inferior, that means has a higher priority, then what will happen? Switch will ignore it. That okay, my priority is lower. So what I'll do, I am the root bridge. I don't need to accept his information. But if the neighbor's BPDU is preferred, wait a minute, if the neighbor's configuration BPDU is inferior, which one BPDU, switch will ignore that BPDU, correct? If the neighbor's configuration BPDU is preferred to its own BPDU, the switch will update its BPDUs to include the new root bridge ID. That means if the second switch is having a lower priority, so that means according to that, he has to be elected as root bridge. So in that case, the switch will accept it. And in the root here it will use the neighbor's ID and here it will use its own ID. Understood? Getting it? That means if you have switches, switch 1 and switch 2, initially both switch 1 and switch 2, they will consider that, okay, switch 1 will consider I am the root bridge, switch 2 will consider I am the root bridge. So switch 1 will use M1, M1, and switch 2 you will use M2, M2. Now, once they have exchanged the BPDUs, switch 2 came to know that, okay, he has a lower MAC address. That means he has to be root bridge. So now onwards, whenever the switch 2 will send BPDU, so in the root information, it will use M1, and in the sending bridge, it will use M2. Understood? Yes or no? Okay. So if the neighbor's configuration BPDU is preferred to its own BPDU, the switch will update the BPDU to include the new root bridge ID along with the new path cost that will correlate to the total path cost to reach the root bridge. That means they do have information about path cost, right? That switch will tell everyone that, okay, for me, what is the cost to reach the root bridge? Everybody calculates, right? Switch 2 will calculate that for me, from this port, my cost is 4. From this port, my cost is 8. Same way, they will include the information. Understood? Yes or no? Okay. This process continues until all switches in the topology have identified the root bridge. So they will keep on sharing the BPDUs with the root bridge ID information. And since all the switches will accept it, they will compare it to their own priority MAC address and all, and they will decide that, okay, who will become the root bridge. Is that clear? STP prefers the lower priority number, then goes to the lower MAC address. So first, lowest priority will be elected as a root bridge. If priority is a type, in that case, lower MAC address will be elected as a root bridge. Clear? Any doubts? Okay. Online people, any doubts in this part?
No, sir.
Clear, sir.
Okay. So once the root bridge has been elected, then after what? Root port election. Okay. So see how the root port is elected. So once the root bridge is found, the switches must determine what? Their root ports. So first is the interface associated to the lowest path host. Lowest path host. That means through which interface they will have the least cost. That interface will be elected as root port. The interface associated to the lowest system priority. Okay. If cost is a type, there are two switches which are available at, if there are two ports, that means we say that, okay, like first is the cost, that through which interface we have the least cost. And then what it says, that the interface associated to the lowest system priority. That means if cost through two interfaces is same, if cost through two interfaces is same, then it will check that through which interface they have the least system priority. Now, if priority is also same, then they will go with the lowest MAC address. If MAC address is also same, like there is possibility that multiple links are associated to the same switch. So what will happen, see here? lowest port priority. Okay, so later on we'll discuss about port priority concept also. So lowest port priority will be checked, and if multiple ports are associated to the same switch, lower port number. That means if port priority is also same, then port number, because switch will not have two ports with the same port number. That will be the tiebreaker. So first will be path cost, then priority, then MAC address, then lowest port priority. You can note these things down. Lowest port number. These are the 5 parameters for electing root port. But in most cases, this path post will do it. In most cases, what will happen? Path post will do it. But if you have from the same switch, you have multiple links, in that case, port priority, and if port priority is also same, port number. Understood?
Any points for lowest port from the advertising switch. It's like whichever is
Sending switch. Okay. So it will check port priority, and then it will check port number. Yep. Now, once your root ports are elected, then what do we elect? We elect designated ports. Okay. Note it. Then for designated port election, just now I showed you that first of all,
Sir, last 2 point, lowest port number and lowest port priority, no?
correct, port priority and port number.
That means
For a particular port also we can set a port priority. Okay, later on I'll show you we can set when we want to manipulate that, okay, how our STP topology will be.
okay, fine.
Okay, so that will be an upcoming concept.
Okay.
This is clear. These two things when you have redundant links. When you have redundant links, that means from one single switch, you have multiple links. Clear? Okay. Then designated ports. So first of all, you check lower path cost. Then you check. Then you check MAC address. Okay. And if MAC address is also same, in that case, same port priority, port number. Clear? Okay. So these are for the designated ports. And once the designated ports are elected, so all the remaining ports will be what? Block ports. Is that clear? The ports which are not the root port, not the designated ports, they are what? Blocking ports or alternate ports. Understood? Okay. Now this is about the table that we will see in some moment. Anything else? So then TCM BPD we will discuss. Direct link and indirect link failures. Okay. Then we have RST. Fine. Now let's go and take a look at the STP output. So I need to start lab.
And then only rate fees will send the BPDs or our fees will
Every switch will send BPD. That is about the TCM BPD, that who will when and who will send TCM. That will come up later. So I'm wiping all the nodes. And the topology also we will generate as we have. Okay, so like this side 0, 0, 1, 1, 0, and 1, 0. So from here, Z0 by 0 will connect to Z0 by 0. Z0 by 1 will connect to Z0 by 1. And Z0 by 1 will connect to Z0 by 0. Now this is the same topology we have. Let's start all the nodes. Let's take an access switch 1. Switch 2. Switch 3. Okay. Now, according to our topology, who was the root bridge? Switch 1. Then non-root bridges are switch 2 and switch 3. So let me just change the host name so that we can know. Host name switch 1. This is switch 2. This is switch 1, 3. And this is switch 1. Switch 1, switch 2, switch. Now let's take a look. First of all, let's say if I go to the switch 2. So according to switch 2, when I'll take a look, so my root port will be and designated port will be Z0 by 1. Let's take a look. True spanning tree. Okay. So if I take, okay, by default, what will happen? It will show you all the ports. So I'll just shut down all the ports except the Z0 by 0 and 0 by 1. Okay. And that I'll do on all the switches. Interface range Z0 by 0 to 3 and G1 by 0 to 3. And I'll say shut down. Which one? Okay. I'm in the privilege mode. Which one here? Which two here? And switch three here. Now let's take a look at switch two. Show spanning tree. Okay. So you can see here Z0 by 0. This is my root port. You can see my port root, right? And Z0 by 1 is my topologies has the same thing. Z0 by 0 root port. Z0 by 1 is the designated port. My cost to the root bridge through my root port. My cost to the root bridge is what? 4. Okay. So let's take a look. Is it 4? This is 4. Here. Okay. Now here you see two things, right? Here you see two things. One is this portion. Another one is this portion. The first portion, this gives you information about root bridge. These are root bridge parameters. Okay. And the second portion, this is what? Self information or self parameters. So here I have the priority. Okay. So this priority means what? This is the priority of the root bridge. Now what is the default priority? I explained. I said 3276, 8. And what is the priority here? Why? Hmm? By default, the priority is basically 32769. Why? 32768 is the priority, and for which VLAN it is 1. So that VLAN ID is also being added here. Okay. So this is what? 32769. Okay. So if you take a look, my actual priority is what? And this VLAN ID is what? 1. So if you add both of them, you get the total priority as 32769. Why? Because the calculation we are having is for VLAN 1. Here. Okay. Then what else? Here you see the address. The address that you see here, right? This address. This is root bridges MAC address. This is the root bridges MAC address. And here, this one. This is the MAC address of the switch. That is switch 2. Now, which one is the lower MAC address? You can see here it is 2 and here it is 1. So lower is root bridge, that is switch 1. So that's why this guy is what? The root bridge. Okay. What is the cost to reach the root bridge? My cost to reach the root bridge is 4. My root bridge is connected on port number 1, which is gigabit Ethernet 0/0. So is my root bridge connected to Z0 by 0 here? You can see. Like if I Now see here, this is my root bridge connected on switch to at the interface Z0 by 0. Right? Then we have some timers. Hello time. So what is the hello time?
It sends BPD.
How frequently the BPDU messages will be sent? The BPDU messages are sent every 2 seconds. Okay. Then we have max size timer. How long your switch port will wait before receiving the BPDU? That means if it does not receive a BPDU from the neighbor, how long it will wait? So it will wait for. Then we have forward delay timer. So this forward delay timer is what? Okay, this you will understand when we study about the port states. Okay. So when we study about port states, we have a listening and learning state there. So how long your switch port will spend in the listening as well as learning state? So by default, it is 15 seconds. That means 15 seconds in the learning state, 15 seconds in the listening state. Okay, so how much time it will spend? Overall, 30 seconds. Why? Because of the power delay timer. This is clear. Then after we have IEEE. IEEE, it means what? Which protocol is running here? No. Okay. In Cisco switches, you will see 3 protocols. PVST, you will see RPVST, and you will see MST. Okay. So how you will know PVST is running? If you see here, IEEE. If you see here, RSTP, that means basically RPVST is running, and MST is for MST only. Here. So as of now, I can see which protocol is running here, PVST plus. Clear? Okay. Then here we have the interface name, the roles, the states, the coast. Then these are the port priority. Then we have the interface number, and then this is the type of interface. So type of interface is point to point. Sometimes you will see point to point edge also. Okay, here sometimes you might see. This is also something you might see here. Okay, so this simply means that port fast is enabled. Okay, because port fast is enabled only on the interfaces where your edge devices or end devices or hosts are connected. Okay, this is clear. Any doubt? Online people?
Sir, this is a default configuration, huh?
Yes,
Or
completely default configuration without changing anything.
okay.
Okay, we can temper the parameters also.
Sir, one more lowest priority switch is added to the topology. Again, the election process is started, no?
Which one? Yeah,
One more lowest switch is added to the same topology. Again, election procedure is started, right?
yes. Okay, because it will also start sending BPDUs.
Yes, yes.
Okay. So this is clear. Now
Yes,
let's take a look at the PPT, what it says about the parameters. These are the terminologies. Yeah. So you can see we will have something called a system priority. So this priority is a 4-bit value, and this indicates the preference of a switch to be a root bridge. Okay. And what is the default priority value? Then you saw about system ID extension, right? This indicates what? The VLAN. Clear? What system ID extension? Just now we saw, right? Here, system ID extension. Okay. Then after we have root bridge identifier. Okay. So root bridge identifier has the information of root bridge, correct? And bridge ID is what? Bridge ID is a combination of MAC address, the ID extension, and the priority. So like 32768 plus 1 32769 and the MAC address. That is your bridge ID. Then local bridge identifier, that is the same thing but for the local switch. Max saves time, maximum length of time that passes before a bridge port saves its BPDU information. Okay, so it will not save it. How long it will wait? 20 seconds. Then hello time, how frequently the BPDU messages will be sent, and it is by default 2 seconds, and we can configure it from 1 to 10 seconds. Forward delay timer, the amount of time the port will stay in the listening and learning state. Default value is 15 seconds. Okay. Then after about root port. So what is a root port? We know that root port is what? A port that connects a non-root bridge to root bridge. This is a root port, right? Here you can see. This is a root port. What it does, it is connecting a non-root bridge to a root bridge. Right? Available on the non-root bridge switches and always in the forwarding condition, least cost path to the root bridge. Designated port also we have seen. That designated port will receive and forward BPDU frames to other switches because root bridge will have all ports as a designated ports. Okay. And you see there should be only one active designated port on a link. On one link, there has to be one designated port. There cannot be two. Then we have blocking port. So blocking port means not forwarding any traffic. Okay. What is the root bridge? The most important switch or the reference switch, you can say. All the ports are in forwarding state and they will be what? Designated ports. BPDU. BPDU is used to identify the hierarchy and notify the changes. So we have two types. One is the configuration BPDU and another one is the TCN BPDU, topology change notification BPDU. Clear? So configuration BPDU, that is the normal BPDU what we use. If you take a look where all the information is being exchanged, all the information. Okay. But topology change notification does not have a lot of information. This only indicates that, okay, there has been a change in the topology. Okay. So TCN used to communicate changes in the layer 2 topology to other switches. Clear? Then root path cost. So the cost we have already seen that this is the root path cost. The combined cost for a switch path towards the root switch. Clear? Okay. Then we have to talk about the port states. So we have these port states. We have disabled blocking, listening, learning, forwarding, and there is one more state which is broken. Okay, this thing you might have not studied in the CCNA. In CCNA, you have studied about disabled, blocking, listening, learning, and forwarding. So what is the broken? The switch has detected a problem on a port that can have a major effect. Okay, the port discards the packet as long as the problem continues to exist. That means there is a problem with the specific port only. In that case, broken. Otherwise, in most cases, it will be like if the switch is functioning properly, then you will see only these 5 states. If the port has a problem, then you will see the broken. Okay. Now, first is what? Disabled. That means the port is administratively down. The port is administratively down. So that is disabled. That means no STP running at all. Once the port starts, the switch port is enabled, but the port will not forward any traffic. Then we have listening. So listening, what will happen? The switch will transition from blocking state and it can now send or receive only BPDUs. So only BPDU messages are allowed. Okay. Then learning. So in the learning, what will happen? The switch will start learning the MAC address table and it will start modifying the MAC address table. And forwarding is the final state where all the traffic will start forwarding. Clear? Now, in short, if I explain right these particular states, so how you can note them down. If I say STP port states. Okay. So one is I'll take a screenshot of this. Then I'll explain in short. Okay, now understand in short. We will just use few parameters to explain it. First is disabled. Okay, number one is what? Disabled. So in the disabled state, what will happen? That your STP, first of all, it will not forward any BPDs, or I'll simply say port is down. Number two is blocking. Okay. So in this case, the port is up. There will be no BPDs. Oh, sorry. It will forward only BPDs. Or not BPDs. Here BPDs will be exchanged. Okay. But there will be no map learning and no data forwarding. Listening state is also the same, because you're listening to BPDs. Okay. Then number four, learning. Your port is in up state. BPDs are being forwarded. Your switch is learning MAC addresses, but still there is no data forwarding. The switch is not forwarding any sort of data. Then we have forwarding. So that means everything is happening. Port is up. BPDs are being forwarded. MAC addresses are being learned. And data forwarding is also happening. This is how you can understand the states. Clear? Online people, clear?
Yes.
Okay. Amount of time a switch port spends in each state. So disabled is a permanent state. Okay. The port comes up in the blocking state. So in the blocking state, it will spend 20 seconds. Okay. In the listening state, because of forward delay timer, 15 seconds. In the learning state, again 15 seconds because of forward delay timer. And then last, we have forwarding, which is the final state. So unlimited amount of time.
Blocking stage at 20 seconds is the max age.
No, that is not the max age. Because alternating port is in the blocked state, right? That is when alternating port is elected, that time it is the final state. The blocking state, that time is a final state. So unlimited time. But initially when you bring the port up, So still it will remain for some time in the blocking state. In the packet tracer, you see the orange icon, right? Why do you see that? Because that time it is in the blocking state. Okay. Then after 20 seconds, it will remain in the blocking. After 20 seconds, it will use 15 seconds for listening and 15 seconds for learning. And then finally, you will get into the forwarding state. Okay. Clear? Then STP timers. So timers are here. You have already noted them. STP timers. So we have these three timers: maxes, hello time, and forward delay. Okay. So hello time, how frequently? BPDUs will be sent. Maxes, how long a switch will wait before discarding a BPDU, and forward delay, how much, like how long a switch port will spend in the listening and learning state. These are the three timers. Okay, so defaults are okay 20 seconds. In this case, it is 2 seconds in case of hello time, and in case of forward delay, it is 15 seconds.
Sir, is this same for all Cisco model switches, L2, L3, or it will change model to model?
This is for the protocol, right? So it doesn't matter what is the model of the switch. If the STP is running, then this is the case.
Okay, but it also depends on the CPU and the memory also, right?
No, no, it doesn't depend on that.
Okay,
It's
okay,
only depending on the protocol. Yeah,
okay.
changing the protocol, like if you're going with the RSTP or MST, in that case, it is different. Clear? Now about the protocols. Okay. So we can divide this thing into two parts. Okay. The STP protocols, we can divide it into two categories basically. Number one is open standard. Number two, I can go with the Cisco proprietary. Okay. So the first protocol was your STP only, spanning tree protocol, which was having the IEEE code .1 B. Okay. And this protocol was taking 50 seconds of time, okay, to come up from disable to forwarding, and 50 seconds of time and only one STP for all VLANs. Okay, when number two, they came up with RSTP because it was taking 50 seconds of time. So IEEE code W, this was taking 2 seconds only. Okay, like 3 times the BPDU time. Then here also only one STP for all VLANs. Now, when you're using only one STP for all the VLANs, you might be having thousands of VLAN, and for all VLANs, all the traffic is passing through one single switch. That causes heavy CPU uses. This is where something was required that, okay, for different VLAN, we can use different root bridges. Okay. So this is where the need of MST came in. So 2.1 S. So time was 2 seconds. Okay, and here one STP for a group of VLANs. Like if you have 100 VLANs, so VLAN 1 to 10, one STP, then 11 to 20, another STP, 21 to 30, another root bridge. Okay, STP means basically root bridge I'm talking about. Okay. Then we can talk about Cisco proprietary protocols. Number one, EVST plus. So there is no IEEE because this is Cisco proprietary. And this was similar to your STP only. 50 seconds of time. And from beginning only, Cisco started working on per VLAN system. PVST stands for per VLAN spanning tree. Okay. So one STP for each VLAN. And that's why when you take a look here at the output, right, it will first define that, okay, what is the VLAN? That for which VLAN the calculation is. If you have more than one VLAN, so right now VLAN 1 configuration, then VLAN 2, then VLAN 3 like this. For each VLAN, there will be a root bridge calculation. Okay. Then when RSTP came in, IEEE reduced the time. Cisco also reduced. Cisco said, okay, fine, we are also good. RPVST, so few seconds, and one STP for each VLAN. One STP for each VLAN. Clear? Okay. Then you have heard of CST also. Stands for Common Spanning Tree. So what is the common spanning tree? See, let's say, example, this protocol is running. Now for each VLAN, what is happening? One STP is getting calculated. But by default, what will happen? Everybody will have the same priority, same MAC address for all the VLANs. Correct? Same priority and same MAC address. That means MAC address will be the tiebreaker. Like as of now, if you take a look here. So in switch 1, switch 2, switch 3, doesn't matter, you create 10 VLANs also. For all the VLANs, first priority will be checked. Priority will be same. MAC address will be checked. This guy will always have the lowest MAC address. So this guy will become the root bridge. That means there is a common root bridge for all the VLANs. CST, common spanning tree. Clear? So this is how the protocols are. Clear? Any doubts? Online people? Guys, any doubts so far? Okay. So then tomorrow we will see about, like BPD guard, BPD filter, all those things we are going to see. Direct and indirect link failures we are going to see. And then we will move on towards RSTP and MST. So probably this week we will just be going with the STP only.
Sir, RSTP and MSTP needs to configure manually, no?
Yes, manually.
Okay. And automatic number is there for STP 32768. Is there any particular range?
Yes, there is a range. Okay, that tomorrow when we will manipulate the root bridge.
Okay.
Today we have just started with the STP, like still 2-3 sessions are going to be there.
Okay, sir.
Okay. Yeah. All right then. I'll see you guys tomorrow. Have a good day.